Okay, welcome to Algebra 2-2, Unit 12, Section 7.5. Today we're going to be working with logarithms. I want to back up just a little bit to, you know that the inverse of logs is your exponential functions. So I just want to review a couple rules from exponents that hopefully you remember. First one was if we have a to the m times a to the n, in other words, same base, and the exponents, the bases are being multiplied, what do we do with the exponents? And hopefully you remember you add those exponents. Okay, so that would be like 3 to the 5th times 3 to the 2nd is 3 to the 5 plus 2, or 7th. Okay, the other principle that I'd like to go over is if we were dividing a to the m over a to the n, that we would take the top exponent and subtract the bottom exponent. In other words, 3 to the 5th over 3 squared. If you picture that in your mind, you'd have 2 3's on the bottom, 5 3's on the top. You'd reduce by canceling those that are alike, and you would end up with 3 3's on top. You also end up subtracting. 5 minus 2 is 3. Okay. Our last one that I wanted to mention was a to the m raised to the n equals a to the m times n. Okay, 3 to the 5th squared, well, that's 3 to the 5th twice, that would be 5 10 3's, or 5 times 2. Okay, so now when we go to logarithms, since they're inverses, we can think back to those properties. If we have a log with the same base and we're adding the logs, then we know that condensed, this is an expanded form of it, but condensed, well, if we go up here, when we added the exponents, they were being multiplied. This time, if we're adding the logs to condense that, we would simply write log b to the m times n. Okay. If we're subtracting them, we think back up to our exponents. When we subtracted them was when we were dividing. So sure enough, we would have log b m divided by n. Okay. And the last one, if we have a factor times the log, then we have begun, or we have in a condensed form, that same log with the base raised to the exponent. Okay? So let's see how this works. If we have log 4 to the 3 divided by 7, then we know that we can expand this to log 4 3 minus log 4 7. Now, what I would want you to do is look up in the directions. I give you an approximation for these logs. I've just simply calculated those for you. And then go ahead and plug those in and finish. So we would have 0.792 for log 4 3, 0.792 minus log 4 7 is 1.404. If I were to subtract those, I would actually subtract the 0.792 from the 1.404, and I would get 0.612 Now the one that's farthest from 0 is the negative, so this answer is a negative. Next problem. Well, I know that I was given the value for log 4.3 and the value for log 4.7. So log base 421, I could rewrite as log base 4.7 times 3. Now I can expand that because I know what the times I add. So I could have log base 4.7 plus log base 4.3. Now I bring in my values. 1.404 plus 0.792. When I put those together, I get 2.196. Okay, so we've practiced each one of these rules so far. We've done a subtraction, which was division. And then we've done addition, which was the multiplication. So the last one here is if we have it raised to a power. Let's see if this is a perfect power. It does happen to be. So it's 7 squared. 49 is the same as 7 squared, so we would expand that out to being 2 times the log base 4.7. Okay, now we plug in our log base 4.7, which is 1.404. Bring down our 2 that we're multiplying by, and we get 2.808. I would like you to come to class with number 2, 3, and 4. If nothing else, just expand these out, and then you can plug in the numbers and you can hold on it and use a calculator in class if you have to, but preferably have them all 3 worked out. Okay, so do that right now and then come back on. Pause the video and come back to that. Here are the answer keys just so that you can check. That way you know if you've got them right. This is a negative 0.263. If you don't have it right, come see me or ask in class. This one would be, let me figure it out, 9, 15, 10, 2.059, and this one is 2.322. So if you got those right, celebrate. If you did not, then let's see where we went wrong in class. That would be a great opener. Okay, so now we're going to expand or condense according to the laws that we just practiced. So if we look at this, it looks as though we have a log base 6. That's 5 times x to the third divided by y. Okay? So the next thing that I want to do, and I realize that would be in parentheses, but we don't really need those, we're expanding. So the next thing we would do is we would say, well, in place of that times is a plus, since we're expanding, so it's log 6, 5 plus log 6 x. Ooh, now that x is raised to the third. We don't show that as an x raised to the third in the expansion. Instead, we bring that exponent of 3 to the front of the log. We have that. And now for division, we have minus log base 6y. Pause the video and go back and see if you understand that from the properties we just studied. Now, the next one, it's backwards of of expanding, now we're going to condense. So in place of the plus, we're going to put a times. So we have log out front. We have 9 plus 2. 9 times 2. Now that 2 should be raised to the third power, because remember that would be our exponent. Minus means divide by 3. Okay, we never have to write the log again. When we're condensing, we leave just one log there. So we have log 9 times 8 divided by 3. That would be 72 divided by 3, which is log 24. The next one, it's all condensed, so let's expand it. We have a log 3 times log x raised to the fourth. That would be a log 3 plus log x. Bring the 4 into the front. And there you go. Okay, change of base formula. These are pretty neat because in a calculator, you can't plug in log base 6, 25. And obviously we can't just figure that out in our heads. So here's what we do. And this is how a student taught me that they remember it. See how the base is right here? Well, they said, take that and make it the base of your fraction. So it's log 3 and log 8. And that's how we're going to change the base to get a decimal value for this, is we change them to log base 10 in that way. So since I don't know if you have calculators at home or not, you can calculate these when you get to class. You'll really plug it in. See me if you don't see the log key on the calculator. You'll plug in log 8 and punch divided by log 3. Let's go ahead and write these down, what you'll be doing. So log, again the base or the bottom one goes to the bottom. Log 8 over log 5. Log, higher one is up high, 14 over log 8. Log 9 over log 26. Log 30 over log 12. Okay? And that's actually how you go through and do them. All of the answers you'll end up rounding, I believe. So just put an approximate or about symbol there. And go ahead and use the calculator when you come to class. That's the end of the notes for today. We'll see you tomorrow in class.